Hello, my name is Sydney, and this is my presentation for Lab 3, Black Hole, for Physics 2211, Section W03. The objective for this lab was to analyze the motion and forces acting upon a star that is orbiting a black hole to determine the mass of the black hole. We used concepts like Newton's second law, the gravitational effects of the star, the rate of change of momentum, and net force in terms of the parallel and perpendicular components to determine the mass of the black hole and to better understand the forces that contribute to everyday motion. From understanding Newton's second law, we are able to understand more about the kinetics of everyday motion. The law states that the rate of change of momentum is directly proportional to the sum of all forces acting on the object, which then can be related to velocity, as the change in velocity is equal to the net force divided by mass times the change in time. Also, that dp dt is equal to the change in momentum divided by the change in time. The next concept is gravity, which is the attractive force from the center of a body on another body, calculated by multiplying the universal gravitational constant by the two masses, then dividing by the radius between the two squared. Thirdly, we have how the mass of the black hole will be calculated, using m1 equals the force of gravity times the distance between the two squared, divided by the second mass multiplied by the gravitational constant. Lastly, we have a sum of force statements, where F net is equal to the summation of the perpendicular forces and parallel forces. In terms of momentum, these two different components are very important. The parallel forces are used to describe changes in speed, whereas the perpendicular forces are used to describe the change in direction. Using the principles I just described, we are able to create and analyze a computer model of the star's movement around the black hole. First, I added my GT email to the section so that my star would have a unique radius of motion. I then changed all necessary initial conditions. So I set the gravitational constant to 6.7 times 10 to the negative 11, entered the mass of the star, then set delta t to 86,400, which is the number of seconds per day. I then updated how the momentum and the changes in momentum and velocity are calculated, so that they are calculated using Newton's second law. Then I calculated dp dt and F net by, once again, using Newton's second law. In lines 178 to 183, I calculated the parallel components of magnitude, and in 186 to 189, the perpendicular components. In line 193, the distance between the two masses is calculated, and in 194, we found the magnitude of the net force. Lastly, in line 195, the mass of the black hole. There were not many changes made to the code in the section currently shown, mainly just formatting. So for lines 204 through 210, I created arrows and added them to the model for the components of net force, and then printed the final values in the end for F net parallel, and F net perpendicular. This was the result after running the simulation. The orange arrow represents the change in net force, the purple represents the perpendicular net force, and the blue represents the parallel net force. The results of this lab was the average mass ended up being 1.58 times 10 to the 34th kilograms. F net was 9.21 times 10 to the 28th newtons. F parallel 4.06 times 10 to the 27th newtons, and F perpendicular 9.21 times 10 to the 28th newtons. So, what does all of this mean? Technically, the values for the perpendicular and parallel force components for the net force and the change in momentum are the same, but they are calculated differently, and they do mean different things. The net force is calculated using Newton's gravitational formula because it is a sum of the forces. On the other hand, dp dt is calculated using a change in velocity because the change in momentum is equal to m times the change in velocity. So, what if the black holes were changed? Well, if the black holes were changed and the location plus motion of the star remained the same, then it would not be possible to determine the difference between the two. The gravitational force does not change, So it would be impossible to calculate the new mass of the black hole because the force is equal to the gravitational constant multiplied by the two masses divided by the distance squared. Nothing else in this calculation changes, so telling the difference between the two is impossible.